Here we are in video 2 of section 5.3, and we were interrupted with the graph, so let's continue with example number 10. Number 10, we have f of x equals x squared plus x minus 56 over x squared minus x minus 42. And I look and say, okay, I can factor both of these. So this becomes x plus 8 times x minus 7, and the denominator becomes x minus 7 times x plus 6. And I notice the x minus 7's will cancel each other out, so we're left with x plus 8 over x plus 6, and this is the more simple function that we're going to be dealing with. So the first thing I need to do is look at where are the vertical asymptotes. X plus 6 equals 0, subtract 6, x equals negative 6. So I'm going to come over here to my graph, and I know x equals negative 6 has to be one of my asymptotes. Okay, next thing I might look at are what are the intercepts. Well, let's do the y-intercept. Oh, let's do the other asymptotes first. The other asymptotes I look at and say, okay, let's see, this, the degree of the numerator is 1, the degree of the denominator is 1, and since they are both equal, then I know my horizontal asymptote is y equals x over x, because I take the first term in each one, which of course equals 1. So y equals 1, so there's my vertical asymptote. And in essence what this does is give us a whole new set of axes, but we're not worried about transformations or anything like that, so these are just the values that we're going to get closer and closer to. So then what we get from here is, let's look at intercepts. F of 0 to find the y-intercept would be 0 plus 8 over 0 plus 6, which equals 8/6, which equals 4/3. So let's see, that's about right there. 0 4/3 is one of the intercepts. Let's look for where would the intercept be the x-intercept. So 0 equals, remember the numerator is the only thing that can equal 0, subtract 8, x equals negative 8. So we would get negative 8, 0. So that would be, maybe somewhere about there. Now realize I have a point. I know I'm bounded. I'm going to get closer and closer out here, and I'm going to get closer and closer here, and I know it's in this section. Likewise, as I come out here, it's going to get closer and closer to that, and closer to this, because I'm in this section. So basically, I have enough to draw what the graph would look like. And it just keeps on going on and on and on forever. And there is the answer to number 10. So basically we just look for all of the things that we've been looking at and just fill in stuff as we go along. Number 11, f of x equals x to the 4th over x squared plus 25. Okay, here's going to be my graph. So we'll put in things as we find it. Let's look for vertical asymptotes. X squared plus 25 equals 0. Subtract 25, x squared equals negative 25. Well, that can't happen, so there's no vertical asymptotes. That's pretty nice. Let's see. Let's see where, are there any horizontal or oblique asymptotes? Well, this can't simplify, so the degree of the numerator is 4, the degree of the denominator is 2, and this is more than 1 bigger, so we can't even do the division, so there's no horizontal asymptotes either. So we don't have any asymptotes whatsoever. It's just going to be some graph. So now we're stuck with things like intercepts. So let's find f of 0. Let's find the y-intercept. So that would be 0 to the 4th over 0 squared plus 25, which equals 0 over 25, or 0. So 0, 0 is a vertex. Or not a vertex, it's an intercept. It shouldn't take too much to realize if we let 0 equal x to the 4th, then x is going to equal 0, so we get the same thing. So then the question becomes, what does this look like? You know, we don't have any stipulations, so to speak, you know. And usually it's about this time that you might be tempted to go to the graphing calculator, which is perfectly fine. And so let's go ahead and do that. Realize we found what we wanted to find. It's just there's some stuff going on here that we need to deal with. So let's go to our calculator, and this might take a little while for me to pull this particular one up. Okay, let's go to y equals, clear out everything I had, and let's do x to the 4th power divided by the whole thing, x squared plus 25. And let's see what sort of graph this gives us. Remember, we don't have any asymptotes whatsoever, and by golly, it just looks like a big old fat problem. So that's pretty much where we're going to be heading. So if I bring it back down to where we were looking, and it's going to be a big old fat parabola. And if I draw this side a little bit better, it might look something like this instead. But there we get our nice fat parabola, and the only real important point on this whole thing is the point 0, 0. Now example 12 is a rare multiple choice that you see in homework, and basically we just need to figure out which rational function might have this given graph. Well, the first thing, that should toss out a, because a isn't even rational, because there's not an algebraic expression in both the numerator and the denominator. So we can throw out a. Now what we want to do is we want to look at, okay, we see a horizontal asymptote. There's a horizontal asymptote of y equals 0. So that means we need to have it so that the numerator degree is less than the denominator. Well, that doesn't help us out. B, C, and D, all of those apply. So that doesn't help out. It appears like we have an asymptote at 0, which means x, just the factor of x, has to be down at the bottom. But here's where the difference comes in. We need to look at, there's a pretty, B and C are very similar. X and 2x, all that's going to do is affect, it's going to compress a little bit. But remember what 1 over x looks like. It looks like in the first quadrant and the third quadrant. So that way, C, it can't be C, because we have graphs in the first and second, not the first and the third. So C has to be thrown out. Likewise, B would be just a compression of the original 1 over x. So by process of elimination, we would see that the answer is D. And once again, it doesn't take too much to punch this into our calculator, our graphing calculator, and see that 1 over x squared would actually fit that graph very nicely. Then the last 3 problems are word problems, and we're going to look at the first one here in this video, and we'll finish the last 2 in the next video. So number 13, we're going to have a can in a right circular cylinder. So that just means a normal shaped can that we are very accustomed to. We need to have a volume of 700 cubic centimeters. The top and bottom are made up of a material that costs 8 cents per square centimeter. So the top and bottom are 8 cents per square centimeter, while the sides are made of a material that costs 5 cents per square centimeter. Find a function that describes the total cost of the material as a function of the radius. So in other words, R is what will be our variable here. So we're going to have the total cost with R as our variable. Okay, we need to think about it. Okay, the top, if we know we've got the radius, the area here is pi r squared. So it's going to be pi r squared. But we have 2 of those because we have both the top and the bottom. So we're going to have to take that times 2. And all of those cost 8 cents per square centimeter, or per every unit in the area of that. Plus, now the side, we need to think about the side. What is the area of the side? Well, the side, the lateral area of a right circular cylinder is 2 pi r h. So that is 2 pi r. But what would h be? That we don't quite know. So we would have to include h as a variable as well. And we know that this is all at 5 cents for all of that. Now we know that the total has to be 700 cubic centimeters. So what we're going to do here is the volume is pi r squared h. So we know the volume is 700, and h would equal 700 over pi r squared. So that means h right here, I can now plug in 700 over pi r squared. So just doing some quick multiplication here, I get 0.16 pi r squared. This would be 0.1 pi r, but I know h is 700 over pi r squared. And so what I get is 0.16 pi r squared plus, okay, that pi will cancel with that pi, this r will cancel with one of those r's, and 700 times 0.1 is 70 over r. And so the final function, c of r, is 0.16 pi r squared plus 70 over r.